Hi everyone, my name's Tony Stillman. I'm the Technical Director, Flying Site Assistance Coordinator here at AMA. But I've been flying models for quite a few years and been involved in a lot of radio programming and repair. And so we're going to talk today about setting up your model with a computer radio and understanding what basic programming is, as well as the proper steps that you want to take while you're programming your aircraft. So we're going to look into the details of that, and hopefully this will be a great guide that you can use on all your future projects. Most transmitter systems today, computer radio systems, have the ability to do airplanes, helicopters, sailplanes. So you want to pick the model type. So your radio system will have some way to do that. So the next step that you want to do is pick the model type. In this case, obviously it's an airplane, so you pick airplane. The model type is important because it's different programming are available between airplanes, helicopters, and sailplanes. Now, the first thing that you want to do is look at the direction of travel of everything. So I've turned the radio on, airplane on. So we're going to look at the elevator in this case. So when I pull back on the stick, I'm getting down elevator. Pushing forward on the stick, I'm getting up elevator. So we know that the elevator is reversed from what we want. So we're going to go into the servo reversing program. So depending on your radio system, that may look different. It doesn't really matter, but it's going to be something servo reverse or something. So you get into the program. In this case, we're working on the elevator. So you're going to, once again, use your system, scroll down to the elevator reversing, find out where that's at, and then you usually have a simple button to push to make it from normal or reverse. So in this case, we're going to go move the switch, and now I've got up elevator for up and down elevator for down. So that's a very simple, easy change. I'm also going to check the rudder while I'm here. Oh, and right rudder is left, and left rudder is right. So that's got to be changed. So I'm going to find the rudder channel and make that change. And now right rudder is right, left rudder is left. Very simple, very quick. Most of you have probably done that. So this is nothing really that new. So let's try the throttle. And throttle is backwards, so we will fix that too. And that fixed the throttle. So very simple, easy to do, got all the channels working in the right direction. Obviously we're not working with the wing, so no ailerons there, so we won't worry about that. The next step that's easy to forget and easy to miss is sub-trim. It's really important that you go to your sub-trim program first, or right after you've done the reversing. Sub-trim is the way in which you make sure that your servos are in an exact neutral point. The servos, as you know, servo arms are going over a round splined shaft that mounts the servo arm onto the servo. So you can move that servo arm around a bunch of different places, but usually it's difficult to find one that's exactly at neutral. So you get one that's really close, then you go into your sub-trim program and adjust the trim of that servo. Let's just say we're working on elevator. Go into the sub-trim for elevator and adjust it plus or minus until that servo arm is exactly 90 degrees across from the push rod. Really vital that you do that on every channel. Down the road, this will ensure that you get equal travel on all your channels and that full throws are available to you. Now we're going to get into the meat and potatoes of adjusting your system. We're going to focus just on the elevator, but all the other channels will work virtually the same. So the next thing will be your endpoint adjustment. Most of the kits will come with a recommendation of how much travel you should have on an elevator or aileron or whatever. So we're going to focus on elevator. So usually there's some sort of deflection, 3/8 of an inch up and 3/8 of an inch down at maximum rate. So you can use your ATV or endpoint adjustment, depending on what it's called in your radio, to adjust that amount of travel. The endpoint adjustment, so we see what it looks like. Let me select it in this particular radio. We'll look at the elevator channel. And as I'm holding full up elevator, I can adjust the travel down or up. Now typically your radio will start at 100%. Most radios use 100% for the nominal throw for the channels. You may need to adjust that up or down, but you want to stay pretty close to 100%. That allows you some adjustment on both sides, and it also gives you the best servo resolution for neutrals and for travel. So you want to keep within, say, 80% to 100%. If you need a little more travel, most radios will go up to 120 to 150%. So you can add a little bit or decrease a little bit so that you meet the factory requirements. Obviously, they're also going to show you where they think the push rod should be attached to the servo horn. In the case of the rudder, the servo horn up here, which hole you're going to attach it to and which hole you might attach to it on the servo end. Making those adjustments can give you more or less travel as needed. So the bottom line is you want to end up with the required amount or the recommended amount of travel to start with. So that's pretty easy to do using your endpoint adjustments. So now we're going to move on to dual rates. Now dual rates are used for setting up an aircraft generally so that it will fly easily at low rate but give you a lot more travel for maneuvers, fast rolls or tight loops or whatever. There's a lot of other reasons that you can use dual rate, but typically that's what it's for. So dual rate is a switch. Most of the radios will allow you to even select which switch operates which dual rate. But right now we're gonna focus in on elevator again. So we'll select our dual rate on the radio system that I'm working on here. And let me get the right channel. Dual rate elevator. And there's also usually an adjustment to make sure which position the switch is in. And that's up to you. You can make the switch to be in a down position or an up position for either rate. So whatever you like. Typically, I've always used the switch up is high, because that's pointed towards the sky. Switch down is low. That made the most sense for me. So high rate would be up, and high rate is really what you just set. That's the typical thing that you set at your endpoint. So the high rate's already set. You don't really have to do anything to it. So you flip the switch to low rate, make sure your system shows that you're in the low rate switch position. And then just adjust however much you want to adjust. So if we're looking at the upside, once again, I can just dial in whatever amount I want. And usually your aircraft manufacturer will give you a number here, say 1/2 inch for high and 3/8 for low. And then you can adjust that, measure it out. And then when you flip the switch back and forth between high and low, you'll see the difference. And more of the advanced radios actually allow you to set the down end or the other end of the travel at a different rate than the up end. So you can do that, you can leave the same. So you adjust the low rate on the upside, low rate on the downside to whatever it is that you need. And now I have two positions for high and low for down elevator, high and low for up elevator. There again, these are starting points usually for the aircraft that they recommend. Once you get out in the field, you might want more or less travel. That's great, but you have the basic starting point. So that takes care of your dual rates. A lot of other people like to use exponential rate. Exponential is becoming more and more popular, and it's a great way to where you don't have to flip switches. It's one less thing for you to worry about when you fly. Exponential rate can be set up so that you don't bother a switch, you leave it all alone, and at high rate you put a good number of a high amount of exponential. This will allow the aircraft to fly around neutral just like it's a trainer. Have very little travel at neutral, but a lot of travel at full throw. So I'm going to put in a little bit of exponential in the elevator system, and we'll see what that looks like. So at high rate, we're going to put in a bunch of exponential so you can really see it. So what's happening, typically the elevator works very smoothly and typically with linear with the action of the stick. But with Expo kicked in, when I move the stick, I get very little motion, and then I get a bunch at the end. It quickly moves at the very end. This is because I've got a maximum amount of exponential dialed in. So what it does, it makes the airplane very soft around neutral, but then a lot of travel at the end for maneuvers. Everybody likes a little different setting, but this is a great way to set up your aircraft, because then it becomes, all the aircraft are easy to fly, take off and land. It's very smooth, easy, nothing's going crazy. But if you want to do torque rolls and hovers and snap rolls and walls, you can do all that. So Expo is a great option. It's something you might want to try if you've never gone into dual rates, but it's something that really does work well, and it's easy to do. You can flip back and forth between the two. Great program for you to test. So the last thing we're going to touch on is fail-safe. And the fail-safe systems are really important, especially with electric aircraft, but they can be important for glows too. You want to look at what is available on your particular radio. A lot of the 6-channel radios and below only have throttle fail-safe, and what that means is if the receiver loses connection with the transmitter, or if the transmitter gets turned off, the throttle will go to idle or whatever position you set. That's really important in a lot of cases. If you have a problem, sometimes it'll help you to identify that you do have a problem. If you're flying along in the air and the aircraft goes to idle on its own, that's a good indication that you're having some sort of either range issue or interference issue or some kind of problem. And that can help you to get the airplane on the ground, find out what it is before you crash an airplane. The other thing is that if you do have a problem, lose range, you'll cut the power, and the aircraft will at least come down close to you so you can find it or make sure that it doesn't leave the site. So that's another safety issue. You want to make sure that you test fail-safe, especially with electric aircraft. You want to do all this setup with propeller off. Make sure there's no propeller on the airplane when you first do the setup. So if you plug something in and the throttle's backwards, the motor comes on, the airplane's not going to take off across the bench. And then as your fail-safe testing works, you want to be able to throttle the airplane up, turn the transmitter off, and after a second or so, it ought to go to idle or engine cutoff at your fail-safe point. Really important that you do that from a safety standpoint, and you should test that at the field at least once. Every day that you go out to the field, when you do your first flight testing, do that test at the field, make sure the fail-safe is engaged and does what it's supposed to do. All right, so I kind of covered everything. I hope this will give you a basic idea of how you should proceed and use your programming. It's important that you follow the steps that we started with today and use the programming to make your aircraft easier to fly. Grab your manual so you understand the process, and I think you'll find it enjoyable and a quick way to get the model ready to go to the field.